Okay, this is a continuation of section 5.5, trigonometric equations in your book. I already made one video where I solved out a bunch of problems so you guys could see how they work algebraically in action. And I'm just going to do a couple more here so you guys can see more of them. First off, maybe we'll do this one. 5 plus sine 3x equals 4. For this one, in the last video, we were alternating between all possible solutions, but we had to write plus 2 pi n or something like that. In this one, we'll just restrict ourselves to solutions from 0 to 2 pi. So find all the solutions from 0 to 2 pi for that one right there. We said before, the issue is solving for x. The x is inside of the sign. So just like in 171, we isolate the sign. So subtract the 5. And I get sine of 3x equals 4 minus 5, which is negative 1. Now we just take the sine inverse, although we understand that it's not necessarily the inverse sine. It's all the angles from 0 to 2 pi that give me a sine value of negative 1. In this case, it's the bottom of the unit circle. You all know that, which is 3 pi over 2. So then we get 3x equals 3 pi over 2. Now, just solve for x using your algebra. Divide by 3, and we get x equals 3 pi over 2 times 3, which is 6, which becomes pi over 2. And we're done. Pretty straightforward, pretty simple. Isolate the trig function that you care about. Do your inverse, essentially, find your angles, and then maybe do some algebra at the end to solve for x. One more, maybe. Let's see, I need a good one. Here we go. Tan x sine squared x equals tan x. Now we have multiple trig functions in the same problem together, so we can't necessarily isolate one of them. And the question becomes, what do you actually do? Well, if we look at it really quickly, there's a quadratic term in there. So there's different things we can do, but if there's a quadratic term, there's a chance we'll somehow solve it like a quadratic. What do we do with a quadratic? We set it equal to 0. So do that. Subtract the tan x over. Then we get tan x sine squared x minus tan x equals 0. And now, let's see. That looks a little bit better. If we were harkening back to 171, we would say once it's set to 0, try to factor it. In this case, there's a common factor, tan x, in both of them. So GCF, factor it out. Tan x times sine squared x minus 1 equals 0. But now we have this factor, 2 factors multiplied together equal to 0, which means now we can apply the zero product property that we do when we factor and set each term to 0. So here, I get tan x equals 0. Here, I get sine squared x minus 1 equals 0. And now just solve both of them. We'll start over here since I'm closer to it. There are different ways to do this. If you want, this is actually a difference of squares. Sine x plus 1 times sine x minus 1, you can solve it that way. To maybe make it easier, if I just add the 1, I get sine squared x equals positive 1. And now use the square root property that we know from factoring. And we get sine x equals plus or minus the square root of 1, which is plus or minus 1. Again, if you just factored this as a difference of squares, you get the exact same result. But now, sine x equals plus or minus 1. What angles give me a sine value of plus or minus 1? Well, that's just the top of the unit circle, pi over 2, and the bottom of the unit circle, 3 pi over 2. That's 2 solutions. Now we go over here. Tan x equals 0. Well, let's see. Tan x is sine over cosine. So anywhere sine is 0, tangent is 0. So let's see, that would give me x equals 0, x equals pi. And then the tendency is to include 2 pi because sine is 0 at 2 pi. But keep in mind, we said last time, When we restrict ourselves to the intervals 0 to 2 pi, we use the interval 0 to 2 pi open. You include 0, you don't include 2 pi. So in this case, we'll just stop at pi, and 2 pi we don't worry about. If we think about it, if we were using that trick we did before to find infinitely many solutions, where we added 2 pi, I can just do 0 plus 2 pi to get that one. So I don't have to worry about it. But in this case, well now, I get 4 solutions. And one thing to keep in mind, both from the last video I made and from this video, yes, that's a quadratic. There's another term floating around. But do not assume, oh, it's a quadratic, I'm going to get 2 solutions. Oh, it's a linear function or a linear problem, I'm going to get 1 solution. It varies. Because of the way we're using the unit circle and the way trig functions work, you don't necessarily get 1 solution or 2 solutions or something like that. Set the problems up, solve them all out, and whatever you get is whatever you get. And keep in mind, just like in the last video we did, sometimes you'll have a problem where there's no solution. So just be aware and pay attention. That's all I'm going to do for these equations. That gives you like almost a half an hour's worth of trigonometric equations solved out. If you think you need more help, let me know and I'll make another video with even more of them solved out. But I'm going to stop this right here just so there's not too much for you guys to have to sit through and watch.